In this episode, I'm going to discuss partial indexing. That's what it's called in Postgres. In other databases, it's called filtered indexing or filter indexes. And the pros and cons, what it is, why does it exist, all that stuff. This is coming up. Welcome to the Backend Engineering Show with your host, Hussein Nasser. And when I learned about partial indexes, I was taken by surprise, because how come I never thought about that before, right? You see, guys, when you create an index on a field, on a table, then all the entries that is in this field are indexed in another data structure, and then pointers to the original data is stored in this index. Obviously, this is changed if the index is clustered versus non-clustered, but this is the idea, the basic idea of an index. It's a b+tree index. I talked about how b+tree indexes actually improve the performance of these data structures. Check out this video right here. If you have a lot of values in this field, then the index also grows in size. And if the index grows in size, the traversal slows down. Not only that, the storage of the index itself starts to take shape. It's gonna take a significant amount of data to store the index, especially if you have a lot of rows, right? So the field values are gonna be diverse, but subset of these values will tend to be either not searched very frequently or not queried very frequently, or straight up not searched at all, right? And those values that are not searched frequently and they are not searched at all are taking precious space in your index. So they are, the moment they are taking space in your index, they are part of this data structure. That means they are carried up in memory. That means they are on disk, right? Because they are taking space in, almost duplicated between the heap and in the index. So they are taking that space. They are taking space in memory because the databases pull the index in memory in order to perform fast traversal in the b+tree, right? So these values are taking this precious space. Not only that, right? They are also updated when a new entry is added to the field, like you add a new row with these particular values that are scarce in search. You're then also doing a synchronous operation to update the index, right? So the database is doing extra additional job to update the index that is associated with this field, because it's just a value that is indexed. The database has to do work, has to do update. If you do an update statement, you change a subset of values from this hot path, hot values that are commonly queried, to values that are not commonly searched, then the database is going to do the same thing. It's going to update the index regardless with these values. So partial indexes come into the picture to filter that, and gives you as an engineer a tool to index what's important, and you can decide what's that, right? So a good example is this orders table, right? Like, okay, I have an orders table, and this is the status of the order. The status of the order is active versus completed. The chances that you are searching on active orders are way higher than searching on completed orders. Does that mean that you're never searching on completed orders? Well, of course you do, right? You're gonna search on completed orders, but it's not as common as searching for active orders. Okay, so plus you have way more completed orders than active orders. That's just by design, right? Through the years, right? If you don't do some partitioning, obviously, then you're gonna accumulate these completed orders, right? So you can index your table, that status field, so that it only contained active order. Index where, you literally just add a where clause. That's the same syntax, I believe, in Postgres and SQL Server. I don't know if other databases support that. I'm pretty sure they do, because it's a very critical feature. I think it's a very important feature. But once you do that, hey, create an index on this field where order status is equal active. And when you do that, the database will only pick up the rows that are currently active and index those. So the index is going to be tiny, so tiny that it can fit completely almost in memory. It depends on how many orders you have, obviously. Even if you have gigabytes and gigabytes and gigabytes of rows that are completed, you don't really care. The search is going to be blazing fast. And why is that? Because you have way less active orders than completed. So a search for an active order is immediately going to be way faster than if you have indexed the entire table with the completed orders, because the query is going to stumble upon these completed orders, right, in the middle of these things, and as a result, it's going to slow down, right, given also the size and other stuff as well. So that's one benefit of the partial indexing. So the index is tiny. If the index is tiny, can fit in memory. Means I save space on disk, I save space on memory, and if the entire index can fit in memory, I think that's an attractive thing, don't you think? So now we have a partial index on the active orders, right? So the existing rows will be indexed. Future orders or rows that are creating in the orders table, if they are active, the database will say, oh, this is active, I have to update my index. But if it's completed, nope. You can update a row from active to completed, and you're gonna update, technically you're gonna update the index to remove the entry, and that's it. You don't even need to index the completed row, because it's, hey, it's not even, I don't need to index it. This particular example, inserts are not as fast because, well, every insert is an active order, right? If you think about it. So if an active order, you have to update the index. You can think of other examples that might be better than that, right? But that made me think. I keep sliding, I don't know why. My chair. As I start thinking more about partial indexing, I wonder about the disadvantages and the cons as a result of using partial indexes. So you see, when I, as an application, query this table, I have no knowledge about what index is, right? Unless you fully architected the whole thing, you know that these are the nature of the queries, right? But if you don't have knowledge about the application, you can't really make the decision to create partial indexing. Actually, creating partial indexes might hurt you. Let me explain. So back in our example, the active order versus completed order, if there's a user experience that allows users to easily search for completed orders, or like the default behavior is to search for completed orders, then the queries will hit the path which is not indexed. And you might say, Hussein, they are going to be slow. So what? Right, they're going to be slow. Not only slow, they're going to perform a full table scans. Yes, that is slow. But I'm worried about the resources on the databases, if enough people executed such expensive queries accidentally, right? So if the default behavior is to search on the path that is not indexed, then the resources used in the databases is going to increase, because you now all of a sudden you have queries that are performing full table scans, and not just one, multiple ones from multiple users, right? If they are going to that path, that will increase the database utilization and might starve other poor users that are doing legitimate stuff. So I think partial indexes are powerful, but it could essentially cripple your entire system if you don't know what the application is doing. So constant monitoring of the queries that is going on is very critical. And designing a proper user interface, not necessarily user interface, user experience. And when I say experience, I mean an API, I mean a web, I mean everything, right? I mean what the application is actually doing. It's your job as an engineer to kind of know this. That's why I find it very difficult, right, as to work in one place. You have to kind of know what's going on in the entire system. As a backend engineer, you have to know what's the database in. If you know and everything about to do with databases and you know nothing about the application, you're clueless. And if you know everything because you wrote the application, but you have nothing, you don't know anything about the database, you're clueless. You have to have knowledge of both technically. And the reason is you will be working with it doesn't have to be like expert in this or expert in this. You can work with teams, that's fine, but just have knowledge, overview knowledge of what the application is doing. That's why communication is very important right here, right? And when you do that, then you're gonna pick the path and you're gonna optimize both applications, right? Because otherwise, how do you know that you are supposed to do that? As an application, if you're backend engineer and backend developer specifically, you're executing a bunch of queries and you have no idea, hey, this is what I'm gonna do. But you don't know how that query is executed. What is it doing? What path it takes? And you say, not my job. You're gonna pay the price because your application is gonna be slow. And not only slow, it won't scale, right? Because, and this doesn't matter, like NoSQL, it's all the same boat, right? It doesn't matter. A lot of people ask you, oh, you do pick relational versus NoSQL. It doesn't matter. It's all fundamental stuff. There is no faster database. You can buy the best ever database or the best ever software, but if you don't tune it properly and you don't know how it works, it's useless, right? There is no magic box that does everything. It really depends on your use cases and it really depends on your application. That's why I always cry in this channel. It's like, guys, know everything that is to do with the things that you're interacting with, right? Fundamentally. Break the frameworks, break the fluff, slash it down, tear it down, and see what's underneath it. It's all simple stuff at the end of the day. Everything at the first principle is so simple. And once you understand these things, everything that's built on top of this is just fluff. That is just calling into these basic things. So if you're using these fluff and you have no idea what's going on, but believe me, this fluff is just getting bigger and bigger and bigger and deeper, and engineers live way over the top and have no clue what they are using anymore. It's sad. It's unfortunately very sad. We're just using black boxes. We have no idea how it works. Yeah, of course, you're gonna get an application run in 5 minutes, but does it scale, right? Does it work? If it breaks, can you fix it? Anyway, that was a short rant. But in general, we're talking about partial indexing. Why we went all the way there? But effectively, just the communication between all the layers in the back end and even the front end, the user experience, really influence the API and really influence everything, right? And there is this debate whether you should design the API first versus the user experience, right? What should you design first? And everything influences the design of the database and the data modeling and everything, right? But partial indexing can give you great performance only if you know the nature of the queries and you know anything that are about to change. Because if the queries are hot on a certain path for certain values while almost not searching certain other values at all, then you can create a partial index on these. But what if the user experience, the application developer, change that? Oh, by the way, we have to add this or other value to search for, and all of a sudden your performance tanks when you search for that new value, which is no longer indexed. So it's very dangerous to use partial indexing if you don't know how the stack is reacting to you and how it's going to change. So in that particular case, it's maybe easier to just do a full index. It's like, hey, I'm going to create an index. I don't want to worry about that. But the larger the table gets, the larger the amount of volume gets. Again, it doesn't matter. NoSQL, it's the same boat, right? It's not using magic. NoSQL is not using something different. It's the same exact technology at the end of the day. It's all b+trees, right? And if you have a lot of values, then more values equal more space equal, okay, you need more memory and all that stuff, right? You can tweak these kind of things, but I would end this rambling video really, because that was that's what it was. I will end this rambling video by saying, okay, partial index is a very, very powerful tool, but I think it's a double-edged sword, and if you hold it incorrectly, it might hurt you. But if you wield it correctly, man, you can slash a lot of things with it. I'm gonna end with that because that was a cool ending. All right, guys, I'm gonna see you in the next one. You guys stay awesome. Goodbye, yo. Disca.